wait for my grandchild. Went to buying zone, fuck with no grams now. Pussy niggas talking, they just mad that they let down. Bad to his face, got him feeling all depressed now. Niggas think they hard, but they softer than a reptile. Bitch, I'm a lion, I'll eat your fucking flesh out. I was born like this, you can check my DNA. They said I was a monster, then I stepped into the game. These niggas do not want it, I promise that on my name. Since I've been getting money, I just watch my life change. Don't throw money at hoes, cause I'd rather eat and save. Fuck the strip club, rather smoke weed in my place. If you ain't bout no money, get the fuck up out the way. If you ain't bout no money, get the fuck up out my face.
In hell, does this idiot kill me? What the fuck? Bro, no way I fucking died, dude. Like, I was literally 1 second off. Like, I should have gone on Merc Treads, bro. God damn it. If I had Merc Treads here, then I would have been so 1v5 right now versus it. This actually pissing me off. This guy's gotten so many ganks. This is so cancer. Anyways. So, yeah, if you're watching the video right now, I'm going to be uh just working on the koi hook some more. Just making it able to work for different scenarios because I want to make a driver that hooks things in the kernel, right? And so, or hooks kernel functions. So I want it to be able to do that, right? Um, without crashing. So we need to handle those different scenarios, and just start, just handling stuff. Like, why is this guy so quick? Why am I being ulted by this guy? Like, what? Okay, whatever. Anyways, yeah, I don't give a fuck about this game, but that's basically what we're gonna be doing. Um, because I tried to use the koi hook and my cheat, and it broke on hooking SDL relative moves. We can go pull this up. So SDL 3.dll. So hooking this, it so it just does it didn't work for this jump. I guess we haven't handled this part, so we're just gonna work on handling this right here, and we'll try to hook something else. I try to replace all the hooks in my current sheet with this thing, and we're gonna find the errors and then fix them, right? So. Little bitch. What's up then? You run this shit, boy? What's good? It's good swing. Let me find out. This guy's actually full lethality. I mean, I'm not gonna lie, that guy might actually be retarded. No, he got the kick off. No. Okay, yeah, my Bowser heard my actually downstream. I don't know how he thought that was a dead person, not Nico, so I think it just suicide, but yeah, so we're gonna work on here. I'm not entirely sure this. Yeah, we'll have to check to see why this crashed here. Because it should have just. I don't know. I'm not sure. So actually didn't look at it once it crashed. I just got off because I was up. Yep, playing Heat Hawk for like 6 hours straight. They literally did that stuff right after um the last video, so I was kind of just doing that. Oh my god, fuck my pussy ass team. Missed that cannon? That's tough. I forgot that Sejuani got completely dominated and he's still winning the game. That's tough. I literally had this guy in a full Nelson, by the way, top lane. So I forgot to bring Demolish, accidentally brought Conditioning. That's annoying. Yeah, so hopefully after this video, we fix much of these errors and stuff. The next video, I should do a video working on a Windows driver. So working on a working in the kernel with the Rust. That'd be pretty dope. So that'd be a cool video. And the reason I want to do that is because I want to. So I've been reverse engineering the rendering system, right, for Counter Strike. And uh, let's see. So render. So in the render, right, I want to draw text to the screen. And I want to use, Direct 2D to do that. And I want to interface with Direct 3D with my Direct 2D system, right? Um, but the thing is, the game doesn't actually use the right format, right? So the format that you want to use is that we want it to use. Let's see what's good real quick. So the format we want it to use, or we want it to have a flag on the Direct 3D creation that says when it's created, it has like flag 0x20. I think it's like something to do with like fucking Direct 3D flag 0x20. Creation flags. So we wanted to have BGRA support. So this will have support for blue, green, red alpha. Um, which, if you read the docs, which I can pull up in a second, you need the support and able to um, have interpolarity, or whatever the fuck. It basically means intercommunication between Direct 2D and Direct 3D. And so when I try to instantiate my Direct 2D render with the game's swap chain, it doesn't allow me to because the original device for the game is created without those flags set, right? Um, yeah, so I was going to create new D3D resources, but it's not really working that well, even with using the game's swap chain and stuff. I'm not entirely sure why that. Yeah, I'm not entirely sure why that is. I figured out a better idea would just be. I literally can't 1v5. Why am I building double longsword? I have no idea, but so I tried to just replace those, right? So if we go to my render system.rs here, I was trying to just replace them with these new devices, but then the rendering system would stop working. Um, and it just wasn't working properly, right? So I would grab the in-game's device, context, and swap chain and factory, right, from what I reverse engineered from the render system. It just wasn't working properly, so I want to try the new idea, which is hooking into the game's startup pipeline, right? So making a driver that will check process creation, and when CS2 process creation happens, it will suspend all the threads. So before they can actually instantiate their render system and whatnot, it'll suspend all the threads and install my hook on Direct 3D Create Device, which will just overwrite the flags every single time to enable blue, green, red alpha support. Right. So that's kind of my thought process behind it. There's probably easier ways you could do it, but it gives me an opportunity to work with Windows drivers with Rust. So that's what I'm going to do because it sounds like fun. Um, and yeah, I need to do it anyways eventually. Write new drivers in Rust, right? when if I want to do stuff in the kernel, right? So it gives me a good opportunity to learn all that sort of the nuances behind writing drivers in a Rust and whatnot. I got two of those stacks. Yeah, so I don't actually want to go with this. I actually built that. What I want is just a stack MR here. I just want to go fucking humongous and go Spirit Visage. And yeah, so that's the idea behind what we're gonna do here. Over the next course of a couple videos, this is gonna be me working on the hooking library and then working on building what are those things called? A hooking library and building a driver for Windows, right? So pretty dope, pretty dope. So if you're interested in Rust and unsafe code, you're gonna be having a fun time because we're writing a lot of unsafe code. So it should be a dope time. So I'm getting pretty comfortable with the unsafe area right now. I'm really liking the non-null, um, the non-null type or structure within Rust. It makes using pointers just pretty chill, having a nice interface to use them. Um, and to know that you're not gonna dereference the raw pointer. If you do dereference the raw pointer, you can check it, right? Because it'll return a none value if your pointer is going to be null. So it's pretty dope. The non-null is super dope. Like obviously, I'm not good at programming Rust. Um, I've programmed it in the past, and I quit for a long time. I programmed it for about like 3 weeks, and then I quit for a long time, and then now I'm back working on it. And I'm just trying to stay committed because I enjoy the language, and I don't know why I quit last time, but yeah. So I'm not a professional Rust programmer, right? So I don't. I know a good amount of the advanced concepts, but do I utilize them? Not well, right? I don't really utilize them, so you'll probably see that. You'll be like, hey, why didn't he, you know, make certain things generic over this and that? It's because I was originally a C programmer or C++, right? And so I kind of have a C way of programming, and I've noticed that. Um, I'm working on it. Yeah, man. Just day by day. So if I come across something, I'm gonna try and make it more rusty, right, when programming. So I will try to purposely like use like even when it might be more convenient to just use a simple for loop, you might catch me using like a dot iter and like dot map and dot for each and then using closures and stuff. Or like, you might be like, okay, you can just use, simply use a vec here, pass it in. You might catch me passing in like making it generic over, something that implements iterator. Uh with a value like type t is equal to a bool or something I don't know. Yeah, so I'm gonna try to make some cool ass code though. So we'll check it out. I'll beat this guy's ass real quick. Like I'm kicking this guy's fucking ass. Oh, and my team is just getting completely demolished. Goddamn. I guess I'm gonna pull up here. Uh, just gonna go with that. Wait, what? What? How did I not kill him instantly? I just auto attacked him 3 times? How did he not die from that? What? Am I retarded? Like, I literally think I was 1 HP. I said they're auto attacking me, just did not die. But yeah, maybe I'm actually have Down syndrome. I don't know. Um, but yeah, so a lot of cool stuff we could do here. This is some of my code from my cheat here. It doesn't really. See, this kind of thing I'm talking about with these non-nulls. They're pretty dope. Like, they have some really nice. I mean, you have these same sort of methods for raw pointers. I'm pretty sure the pointer type has these same methods, but non-null. Let me think. I think non-null is just nicer because why is it nicer? Because if pointer is the same thing, man, I don't know. I guess because you're guaranteed that's non-null, and if it is null, then it will return a none value, and you can check that, right? Um, yeah, I believe that's why it's pretty nice. Bro, I didn't proc that. God damn it. It was a. I just don't have enough CDR, I think, right now. Let's pull up on this. Oh, he's already got that shit, okay. I think we're just gonna go random. Well, no, they have no crit at all. So, we don't want to go random. So, I guess we're just gonna go Jack Show here. Yeah, that's super expensive and it gives no CDR, though. This guy is so useless. This guy is just so fucking pathetic, goddamn. Or can idiot go idiots back off and not suicide? Bro, oh my god, are you kidding me? I died? How did I die? I really just him because I have no armor, don't I? Yeah, that guy one shot me. I mean, yeah, that's kind of tough. I think I'm just gonna go Sterex. I think Sterex is pretty chill. I mean, well, the game's over. I don't know what I'm talking about, but I mean, these idiots all suicide before I got there, so it's like I don't really know what to do. I guess one even wins the game for free. This guy was completely worthless all game long. Like, what the fuck is this shit? He sat in her tower, did nothing all in, and then just wins the game from doing really nothing at all. That's respect. Alright, well, whatever, fucking, I don't give a fuck. Mary Jane. Yeah, so, alright. Um, so let's just make let's see. So let's go to Koi Hook here. Examples. So our current override hook implementation works for this. So we're gonna say for I and 0 dot 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 10. What do we need to we're gonna say 4 underscores. I'm actually gonna use that. And then we'll just print this out 10 times. Well, actually, this will always. Let's make print name take 2 parameters. So let's give it a value by 32. So let's actually give this an I. And then it will just return I. Let's see if this works. Cargo run / example overwrite underscore. What's going on here? This also is take a value by 32. So this will need to take the value. Because we're hooking it, so it'll take the value, and then we just pass it into here. And yeah, okay. Here we'll return value. Alright, so we. Alright, it goes hard in the paint. So hooked input value was this. So we start off at 0, right? Return 1. So yeah, I mean, yeah, so yeah, it works pretty well. Disassembler goes hard in the paint here. Does a little bit of action here. The problem is hooking other functions, right? So let's see. I wish we had more like a easier way to test this here, because if we want to do it internally, hook things from like from injecting into the game and hook stuff, without having to fucking hope it doesn't crash, right? So let's go to our cheat here. So CS2 internal. I believe I put it in cheat as the startup. I just commented it out. So yeah, I was just testing it here. So, and it is in the hooks here, which we set up just a simple hook here. Well, it just gets the function pointer. So yeah, original set relative, new set relative. So original. So we're gonna have to store original function here. So we don't actually care about transmitting this, actually. It's not at all what we want to do here. And this can, as far as we care, can just be a use size. Let's see, what does get proc address return? Let's take a look. In the Windows Rust here. So it returns a far proc. And a far proc is just it is just a type of function. Yeah, so we're just going to unwrap this. Or well, we're gonna say expect. Let's just make this a little bit better so we can see this well. So let's just do like let's just factor this out real quick. Uh find underscore function. So pub fun, right? So we're just gonna find a function here, and it's just going to take a pointer to a wide, or a pointer to a C wide string um, module, and then a pointer to a C string of what's it called name. So we're just gonna so name. I'm gonna paste this right here for now. Here, we're gonna pass in module and name. Right, and then this will just return an option of var. So I believe that will be Gucci there. And then here we'll just call so if let sum func is equal to find underscore function of this. So if we can find the function here, then we will do all this. Else we will log it. So log a warning failed to find a function. Right, so or we could hmm. Alright, yes, we'll do that. We'll do it like that. So then we need to set up hooker to return back a pointer to the new function. Let's go into our hooker here. Or well, hooker is koi hook. Um come to overwrite hook. So overwrite hook should actually return a non-null UA, so pointer to the function. So it will return new target. So that's our new target's location. So we can actually just cargo build this, make sure it compiles. Okay. And then let's go back to mod.rs. So this will return the original function. And then original function will be a koi, or not a koi, it will be, what is it? It will be an STL relative. All right, so we're going to call standard mem transmute on this dot as pointer. So we're going to turn to a pointer and call standard mem transmute onto it. And then we will set that as our original function here. Here, we're just gonna do the simple stuff here, get window, pass a toggle in, do all that. Yeah, so pretty chills. And so with this, we can now check to see if this builds. And we had a couple errors here. So pointer to wide string not found. Okay. Windows core. PC wide string. So we're just gonna go ahead and just include everything on Windows core here. So skip that. All right. Cannot find type var proc. Unless I'm using a type parameter. So var proc actually is an option. I just realized that. And var proc is from Windows Foundation. So I'm just gonna use that here. Not found in the scope. What? Oh, okay. So this is kind of just fucked up here. So found function. So we put a func as size. I should start into some U8 here, and we don't have to do that here. I believe we should be able to do this, or do this. Uh, Turn a function into a pointer. Let's see. Use dot OK. You want to discard the result. So it needs to return a result. Okay. We have to check that here. Call to an unsafe function. So standard mem transmute. Okay, so there's nothing cast. Head to an unsafe block. Alright. So I believe that's Gucci now. I believe that is Goop Changton. Okay, so we're gonna check to see what exactly happens to our dissembler here. So just call make. So operand 0 register 9 is not between racks and R15 inclusive. Alright, so we see what it's doing here. So it finds this instruction, right, which is a relative jump. And it says we're going to patch it, right? So found relative instruction patcher. So jump to keyword pointer. Alright, so jump to keyword pointer to here. Alright, so we haven't done the keyword pointer here. And then it's like patching this. And so it tries to. Yes, I see what's happening here. So if we go to coy hook, and we go into dissembler here, so it finds a relative, right? So found relative instruction patching. Okay, see this? So found relative instruction patching. It then comes into create move. Then tries to create a move, right? So create move 64 from relative, which will take in the current instructions or register as op 0. Okay. So that's why it's like, oh, question mark, register is none. It's because I don't know why this registers as a relative, like, I don't know, that's just, to me, that doesn't make much sense here, because this is not, I mean, obviously it's a relative, right, to the RIP, or to this address, but it's not, it shouldn't be doing a move, though, is the real thing, is what I'm curious about. Why does that count? So is underscore IP underscore relative memory operand equals true. I guess we should say and it's not a jump. right? To make sure this is not a jump that it tries to do this to. So I don't really want to do that for relative memory operands. Create a an absolute memory move, but so let's go to the ice to x86 here. Or I so let's look at instruction. Jump. So I guess we should probably do this after, right? We don't actually need to check the op. We can just have this be a list of um as near branch. So let's see, instruction. Is there like a type of instruction here? No, there's not. Uh, gets the instruction code mnemonic. So what the fuck is a goddamn mnemonic? Oh, so mnemonic just gives back the mnemonic. Okay. Oh, that makes all the fucking sense. All right. I guess we really want to just do because we don't actually want to get op zero kind, right? Because near branch, far branch, immediate, or maybe we do want to swap an op zero kind. Well, no, because we really want to say is underscore jump, right? So we really want to do this. Like, if it's one of these, then we need to do something, a different thing for each of these. So we don't really want to do this right here, right? We want to do like so. If let's see, where's the start of these jumps here? So what exactly is a near? JCC near. Okay, not it trying to give away my address again. What is with this fucking shit? Like, like what the fuck? JCC near x86. Like I was typing near and nothing shows up, but I see near right here. That's a bit weird. So I guess we would like, so we would just like to do here. So if ends dot is a jumper near or is a not a JCC but it's a jump short or near, we will say found relative jump found RIP relative uh jump near or short. All right, because we don't actually really care about that. Then so we can actually get rid of that. Then we can say if what is it near? Is near because far is let's look at the x86 reference because I don't know the fuck. So JMP far. Jump far absolute address given an operand. Absolute indirect. Okay, so E9s are jump near relatives. Okay, so we can't really do that. We're gonna deal with this. Okay, so all right, so jump nears are also E9s here. So we want to do jump short only. If it's a jump short, then we're not going to give a fuck about it. If it's a near though, then we're gonna have to check them out. Yeah, I mean, if it's a near, gonna have to check them out though. So this one is an FF here. All right, so it's a 48 FF, of which I believe it is. So it has the Rex prefix. Yes, I believe it is this one right here. So it has a 32-bit offset. I guess it's this one actually right here. So jump far, absolute indirect, address skipping. So this is a jump far, right? Send a jump for relative MO. Things that has a Rex prefix. It could also be what is the /5? So near jump, a jump to an instruction within the current code segment. Segment currently pointed to by the CS register, sometimes referred to as an intra-segment jump. A near jump where the range jumps is limited to okay, far jump, a jump to an instruction located in a different segment than the current code segment, but the same privilege level. So far jump jumps to a segment to a different segment. This shouldn't really jump to a different segment. So we show the text. Actually, it jumps to this address, right? See, it jumps to this keyword pointer, so it dereferences this and jumps to this. Which, yeah, that's not really anything too crazy. So I believe this is obviously, this has to be a jump near of a 32-bit memory value. Well, this is not supported in 64-bit mode, it says. Mode. So if you're not supported in 64-bit mode, can it actually do that? I don't know, I guess we'll find out right now what it is. So if JC is short or near, see, no, we have to say, is it a short or is it a jump short? And then we will just ignore it, right? Because we don't actually care about that. If ends dot, let's see. So now we can check to see. So we check is JC short, is okay. Now we do, I guess we'll do jump nears. So if it is a jump near, or is there a jump JCC near? Yeah. So, or is it a JCC near? Then we will log this. Found near jump. Uh, found short jump. I guess we don't really care to log that. Found near jump patching ends. Okay, so we will do something to that here. Uh, if ends dot is underscore jump underscore far. So it's if an intra segment jumps a different segment here, right? Okay, different segment, the current segment is referred to as inter segment jump. Okay. So if it's an Jump to located in a different segment in the current code. So it can be an absolute indirect or address given in here. Um, yeah, so we will just do the same thing we did there. So is it a jump far? So we have a jump far or near jump is jump underscore indirect. So which is a near with a reg slash memory instruction. I think that's what we have over there. So if it's a indirect jump, then we're gonna want to check that out. So it is jump underscore far. Uh, it's kind of the same thing for if it's a call far, right? Because if it's a call far, so log info found far jump slash call. Right, because these are kind of the same thing that we're going to be handling, right? If it's a far call, then we will have to update its offset, right? Well, call far gives you an absolute, unless it's an absolute indirect. I guess we'll really handle these jump nears, JCC nears, jump far, and call fars the exact same, really. I believe so. Will we jump near indirect? Will we really handle those all the same, though? I think we will handle them all the same, because it should just be, right, should the jump far indirect? Uh, why is this? I don't know what's going on there. There's a random I in here. So found jump patching. Honestly, I think that's chill right there because that's really all we. It's call underscore near indirect. Uh, his jump underscore far indirect. Okay. Found jump patching that, right? So we would patch the jump. Uh, found jump slash call patching, in which we would just do what we did over here. So create far branch from near branch, just because it's not really a fitting name, but what will this return? This will return a result of instructions, so we'll pass it ends. It just takes ends, right? Takes an option to the original function call, so I guess we'll pass it in two. So original function call and target underscore location. And then we will just say let instructions equal. And then I think we just did new underscore instructions dot extend from slice. Just passing this, right? I believe that's what we did here. Yeah. Oh, what the fucking shit? Put it in the wrong thing. Alright, so that's how we're gonna do that, I believe. Neutral state is empty, neutral state is push. Okay. So run our example real quick and watch it crash real fast. Okay. Cool. So where did it crash at? I don't understand. Just don't really need this right here. Get rid of that. Alright, so we get rid of this. Why? We're getting an access violation here. That's a bit odd. Uh, and it's never finding this. Target function should have one of these to create fire branches on. Does this instruction shit not? Like, what the fuck is going on with this instruction shit? I know 100% that overwrite hook. Let's see this. I'm sitting. Yeah, so print name has jumps right here and calls, and it's printing nothing at all and crashing. So this is an E8, in which we know that that means E8 are calls. So call procedure. Call near relative displacement relative to next instruction. Call near. Call near. Are we not? Do we not have that here or something? Like what the fuck? Is underscore call near. Uh, is call underscore near indirect. So we don't actually have ends dot is underscore call underscore near. So we'll add that. Maybe that's why. Is JCC near ends dot is underscore j or jump underscore near. Okay, so now it works properly, in which I guess those were near calls. So found jump call pattern, yeah. Okay, so that works good there. Um, so yeah, so these should maybe all be handled the same. We'll see. Maybe they shouldn't be, and we will find out. Relative operand should be handled like this, I believe. So we can check this out for our new thing here. So let's go and retry. Uh, okay. So it actually did do a little bit more here. So it found the jump call patching, right? So it found uh this jump here. So I found jump call patching, jump keyword pointer, whatever the fuck. Old instruction was this. New instructions call to racks. Yes, I tries to call this instead of jumping to it. And then it tries to do something retarded as fuck, which is this. So we don't want it to be a jump now, do we? Right, so let's open our other project here. So CS2, CL3. So we want this to say a jump, but a far absolute. It won't want to be an absolute jump, right? It's the thing with this. So JMPs, right? So you can do a jump absolute if the address is given in the operand, right? So we're gonna have to actually make another change here and separate these out, I believe. So the jumps and nears and stuff, right? Then we have to put else if statements too, because then it tries to then do this also. Else if uh is an memory operand, then we will do this. Right. So here we need to separate the jumps. And yeah, so jumps and calls need to be separated. So it's call near, call far, call indirect. I don't actually have that defined in my config. Okay, I can't do that. Is jump far, yeah, so and is call near is call far. So we would actually want to do this somewhere else. So we're gonna do here else if oh, I guess see what it's doing here. So we're gonna say else if it's a call near call far, then we will create call from near or from indirect call. Uh, so we will do that here. And so we will actually go and rename that. So create call from direct call. Because that's actually what it's doing here. Create call from indirect call. Okay. Here now we're going to have to create a jump from an indirect jump. So found jump patching. Okay. Found call patching. So then in here, we're gonna have to do basically the same shit as this thing, right? I guess that's how it's gonna format it. It looks a little bit clustered up here, but it's whatever. I guess the rest formatter is kind of just going crazy on my ass. All right, so this will be create off indirect call. Okay. So create jump from indirect jump. I guess we can just copy this entire thing here. Again, I don't wanna up. I just wanna up. So can we do that like that? It's really just that simple to change here. We could just, add a little thing here, but for now we're gonna keep it just simple. Keep it simple, stupid. Great jump from indirect. I guess you can do that. So we will create jump from indirect jump. Turn the instructions here. And we will run our example here. And we're still Gucci with it. So pop in here. Now we're hit a little inject Sharino. Which it instantly crashed. That has to do something with modded RS here. That has to be something to do with this, so we're not going to worry about that for now. Oh no, it's going to be because our function. So I would like to just not actually perform the hook yet. Like not actually instantiate the hooks. So let's just go and switch that off real quick so the hooks aren't actually hooked inside. So we actually won't relocate a detour yet. See, like this is what I'm saying. I wish I had a better environment to test because we do want to relocate the detour to see if it actually works. But it's gonna, if it crashes instantly though, we can't. Well, we can actually use a debugger, so that's chill. We'll redo that. Use a debugger here. Only recording for 1 hour? Damn. Okay. Not bad. I'm making good progress in 1 hour. So we can just chill here. Turn on some love letters real quick. Get getting high, smoking dope, getting high, smoking dope. So do a little attachation here now. If we crash, it'll stop it from crashing us. And then we can read the memory. Let's go to the RS here. So I like to print out new detour. So I'd like to log new target. So new underscore target and new underscore detour. Let me just test this real quick, see what it looks like. So it'll give us our new detour, new hook here. Yeah. Smoking dope, getting high. Smoking dope, getting high. Smoking dope. Getting high, smoking dope. Getting high, smoking dope. Alright, so let's go to our internal here. We are up in here. Okay, so we can just see. So it goes crazy with it. It actually sets up everything here. That. What the fuck is that right there? 7 FFF. That's within the disassembler there. So why are we printing out a random ass shit in disassembler? That's a displacement in the original. I can just get rid of that. I don't give a fuck about that. So it's breaking here. I'm able to verify checksum. So is this actually our window? Let's check this. This is actually an SDL window. Of course I did that. Classico. Yeah, I mean this is the SDL window right here. We can see that. The toggle is set defaults. Okay, so that. So what exactly is happening here? So call stack. So we're actually being called from the original thing. Here's info systems calling us. Which is kind of cool, Leo. The question is, why is this breaking on here? Access violation. Moving a moving dereferencing racks. And it is a random pointer that doesn't make sense. Okay, so that's what's going on here. So original function is failing to be set, but our hook is actually instantiated well. This might... No, we're unwrapping it with the question mark. Let's go find out what it is. Let's just stop debugging here, close it up. I'm curious as to why the original function is not being stored properly. Or the new SDL relative function here. Honey, go down, down. So it's not actually saving my fucking. Alright, let's open up the executable. Every time the voice so monotone. See what she wanna be. Let's see. Mm, 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 mm. Oh, it's probably because Hasbro cheat doesn't know how to handle or hook doesn't know how to handle something like this because this is inside the relative hook function, so when it relocates it, this is just some bullshit, right? So even though it sets this here and then tries to call it, it has no idea how to do that, right? So let's. Bro, can you fucking just open up, dumbass? Like, stop fucking pausing this shit because the DLL is being loaded. I don't give a single fuck. Jesus, man. Uh. Breakpoint one's offset. So this is new target, which new target's probably good. Like, there's not really much to change here. It's just going to jump to this direct address here, and which this address is. Oh fuck. Well, it's a bit of a problem actually because it wants to jump not to this V table, but it wants to dereference into it and jump to this address, right? It wants to jump to this function here. So that actually isn't going to work anyways, because it's going to jump to a V table. So that's not going to work. What about the new function here? How's this looking? So this is our hook function. Um, I think it's long as hell, dog. Yeah. So new instruction is move zero interacts and then call Rex. Yeah. So that's where we're gonna run into a couple of issues here. That is where we're gonna run into a couple issues. And then here, um, so found jump patching. So jump keyword pointer, no instruction. So yes, it's not dereferencing that value, just the ish. So we're gonna have to fix that, I think. And then, yeah. Um, and then we don't actually need to do fix-ups on the original address either because we're storing the new address and calling that into our cheat. So the new target should actually doesn't even matter anymore. So that kind of is out of the window, not really mattering. Right. We don't need to update the new address like we did. So that was kind of stupid of me to do all that shit. Honestly, we could probably just get rid of that. Like we don't need to patch the new address because we're not actually gonna call that ever. Right, so we can just go and get rid of that actually. Uh, Here, we just get rid of all that shit. Callbacks at the end. So disassembler. Gonna just get rid of target, new, and old. Um, and then this can actually get rid of too, get rid of the entire thing. Same thing for up here, get rid of the entire thing. So we're not actually gonna be dealing with that anymore because it doesn't matter. Okay, let's get rid of this instruction printing because we have to print off the instructions anyways. Get rid of that. Okay. Yeah, so that's chills there. And the lib here. So we're not using any of that anymore. That was kind of pointless. Target new and old location. Skip that. Let's see, relocate targets chill. We have to do that for this. Well, we need target old location. Right, we're gonna need that. So target. So we are using that pretty frequently here. Why dereference here for target old location? I'm not sure what exactly is going on. Is it being overwritten somewhere? Oh no, because it takes a non-null inhibitor as past reference. Okay. And then in our overwrite hook.rs here, we will actually let original underscore print underscore name for this. And then we can just store that as just a global here. So we just steal that from other code. Let's go grab that. Oh no, mod so just grab this little thing right here. And so original print underscore name. Its type will be okay. That's not where I want to fucking go. Mod.rs, no. Override underscore hook. So SDR relative underscore t. So this will be print name t. Be a function that takes a string and not 32, and returns not 32. So here we'll just standard mem transmute this return value into a print name key. And then we will call original print name t dot set original print name. Right, so original print name, set that, and then we will, in here, we will call original dot get dot unwrapium, and we'll pass in name and the value. Let value equal this, and do the same shit like that. So that's about how it would now be, right? So if we run this example, let's go grab one slug here. So disassembler source disassembly. So expected original function. So we're actually just gonna go ahead and get rid of that. Process instructions expected. Because the arguments for one was the pride, fix up relatives. Uh, call to an unsafe function. Okay. So yeah, input value was koi. So it successfully hooked it, but then this original printing shit is the issue. Status integer overflow. Now, how is that possible? Alright, so let's look at one slot, make sure I'm actually using this thing correctly. So one slot. It's thread safe one slot. I'm using statics minus because use those log set again benefits less effort. This reference to underlying value turns out if the cells are initialized, are being initialized. The input's deref there, right? The lazy lock input's deref, okay. I mean, once I look, it will work here. I don't know why it is failing here. It must be because of the underlying assembly that's generated here that we're not handling properly, and therefore it's fucking up. So let's go check that out. Let's get rid of this. Crack me's here. Let us import a new. I guess I can just type pwd, can't I? Oh, I can't copy that though. Target, debug, examples, overwrite hook.exe, file names, it's 4. Let's stop debugging that. Excuse me. Let's analyze it up real quick. Yeah, something that actually matters. I think it's automatically. Uh, Pretty sure non-null has the exact memory layout as a null pointer. So covariant, what does covariance mean again? Subtyping is an implicit can occur in a state and checking inference. Subtyping is written on two cases, variance with respect to lifetime between types. It's the same size as mute t. Okay, cool. So yeah, that's it's the exact same underlying data. It just has a little wrapping tin around it. Go to right hook command here. Not sure the decompiler is failing, but yeah. Sequoia hook new. Load in print name, whatever, bro. Okay, can we print name underscore hook? It's print name hook. We have scary 4. Okay, not scary. Scary 4. I guess. I don't know. So we have the once lock here, which calls to original print name. So we call once lock get after loading the effective address of original print underscore name. So let's run this and see what exactly December do we have. So found relative instruction, patching, right? So panicking, panic underscore const, panic const add overflow. So exit status X violation. Is it access violation now? It is pointer. Is something different? I mean, I don't even know why I just tried that. I know it's nothing's gonna change. I just figured that out a second ago. Fucking fuck me. Um, some extra space for the detour. This is a jump conditional. It's a jump short, right? So jump short conditional. So we won't actually affect that. Found about 200 patching, so here this will actually changes into a move racks. It looks like well no, it looks like this is actually what it will do. So let's add an RCX. Okay, we found a call instruction here to panicking. It kept saying move racks and call racks here to A0, which is correct. Okay. Okay. So yeah, found call patching. So I'm guessing this is kind of a problem here. So found call patching. So we found a call to racks. Where the fuck is that? So call. So we got a call to racks right here. And what is racks? Racks is some random variable, I guess, which it's calling it, and we then try to update it to move 0 into racks and call racks, right? So it's going to call on a pointer and it's going to crash us. I'm assuming that's the problem here, which we'll have to fix that. So we're gonna have to go to our code and fix that here. So lib.rs koi hook. Okay. All right, and so compilation racks. So call racks, move 0 racks. So found a call patching. So right here, if we create call from indirect call. This isn't an indirect call though. It is call underscore far. That's a name and it's just no, that's a shame. Please not name why these wanna go against the grain. I mean having to bleep myself. Nah, that's tough. Hey, it's tough out here. Yeah, I mean we gotta watch out. Got to boot myself out real quick. But let's see. So call racks. How's it gonna fix that? I guess we can check if the X guapa bitch. I'm just petty. Up up petty. So is call far indirect? So memory location. Yeah, so indirects are memory locations. Is call underscore far. So because it's a 0xff here. Gangster, he's a baby G. Yeah, so it's an FF here. Call near absolute indirectium. Call for absolute direct. Aim as you know, that's a shame. Saying telling wanna go with. So it could be a register or M64. So it's one of this right here. For mode valid, call near absolute indirect. Address given in a register or 64-bit memory location. Is there a way to check that? I guess we can log. I want to know. I guess it would be op1 because this says apparently this can be near branches and stuff for the first one, which is like what the fuck. So I guess we're gonna say op1 underscore kind. So let op1 underscore kind equal ends dot op1 underscore kind. If op1 underscore kind is equal to a register, uh, is equal to an op kind in the register. Really, really worth it, yeah. I'm high right now. I don't wanna lie right now. Being on the opera number, see also op underscore register. So if it's a register, then we will log info found call to register, and we will print out the instruction there. Else, we will perform this stuff here. I guess we can just do this. Found call to register, call this. So no, that's not at all what the fuck is going on here. Yeah, found call. So found call racks, that's right. Uh, but found call register this, like that's not even fucking close to what it is, but yeah. Color of my skin, I'm not with it's a sin. Me, I can get in that bitch. I guess we could try to see op zero underscore time because that found call to register Rex. I ain't your pappy, I ain't your pappy. So found called register call Rex. Donald Trump, I got up, fucking up, oh, got up. I might change the color of my skin. It's a sin. Me, I can't get in that bitch. I ain't your daddy. I ain't your pappy. So let's go to overwrite hook here. Let's just not call anything here and let's just loop. So let's loop here for a minute and just chill out and all that call and shit. So to check out. So this should be our detour. So it's going to attach to overwrite hook. What the hell is that? I was in the back, now I'm in the front. I was in a dark place just last month. Quality complaint. I was in the back, now I'm in the front. I was in a dark place just last month. First off, first off, pass me that dude. Cars. So why does it have a jump here at the end or call? I know better score. Is it failing to jump to the rest of its bytes because we have a return here? With me fuck, with me is and I'm gone. Doing hella drugs. Put up the plug. And we smoking real good. Yeah, I'm high like I should be. This looks literally nothing at all how it's supposed to. What the fuck is going on here? Am I stupid or something? Because this literally looks completely brain damaged. I mean, we see the call racks down here, right? Let's call. But now I'm in the front. I was in a dark place just last month. Quality. That stuff is right down there. Call the photos. Jump if above. Okay. Why is the entire function right here though? Shouldn't it be wait, new underscore detour? This just returns detour, right? What the fuck is happening here? Compilation. So done setting up extra space for detour. Create jump one, let the jump. Disassembler. Create jump one creates a jump, right? Yeah, it does. So we're kind of just pinning the bytes here to the end. That's not really working out that well, looks like. For these leftover bytes, though, these are kind of looking strange here. Because obviously it's going to be a lot larger, right? Come across the 0xCs down here. Where the fuck are the extra bytes at? Or am I retarded or something? Because I'm seeing no leftover bytes here anywhere. Um, Not sure what the fuck is up with that. So detour bytes is drained here. So we calculate the size relative to the instruction. The detour size minus size diff minus 12, which is the length of the jump. So how the hell is this happening is the real question. Because I'm seeing no jump or anything anywhere. It's compilation here. So relocating target function to this address. Current size is 6, 7, apparently. So we can look at target function. Target function looks good here. The target function looks how it did originally, except just updated, right? This one though, sub 0x88. We're still in the original function of E0. But because we're returning detour here, we're supposed to return target. Okay, I'm done this. Anyways, because target is a new location, so I'm looking at the original function here. Like if I'm gonna do it, target underscore old location. Okay. So that's gonna be the target old location, which we can study with this. Now that looks better to me. Though um, the jump is not here, which makes me wonder, right? Because it doesn't actually look like we need the jump, it seems like. But we should need the jump, though, is the thing, right? That's kind of the problem, is that we should need the jump, but the jump isn't there, though. So call to Rax is good now. Just dereferences Rax. And Rax is RSP plus 0x78. Okay. Uh, okay. So what the fuck is at this address? What the hell are we jumping over here? It doesn't look like anything's over here. But I guess there's something here. What's going on here? Move Rex. This, call Rex. This is another one of my located functions. Is this the OG function? What the hell is this shit? 5400. What the fuck? Detour larger than target allocated space for detour. This is the detour here. This is a detour address. Or extra detour address. Why the fuck is that just in the middle of the bytes though is what my question is. How the hell did the ending part just get chucked into here? I guess, well, uh, this must be, so it's never actually going to return here. This must be all the extra bullshit from the original function here. Slot effective art address. Like right here, after this jump racks here, 30. So FD, right? If we come into here and we look at print name hook, so 14, oh, looking at a different function, but FD. Oh, we did the load in the new new function here. Okay, let's load in the new one. So I need to look at this to make sure. Just cost for 5, I guess. Fuck it, we got so many goddamn things that up in here. Not analyzer, go to analyzer real quick. But when he hauled it over, or just some I got time for the shit. So yeah, this must be the ending here, where we ran out of space, right? So look at our overwrite hook. We'll look at it in a second when these things ran up. It's an oh. Uh, Ice. Alright, let's go here. I don't want to call. I don't worry about that. Alright, so we end at somewhere like fucking none of that. Well, let's scrap a little bit. So this is the original function, so it has barely enough space, right? And our function here is big as hell compared to this little thing right here. Um, right, so this thing should be good here. So yeah, it looks Gucci here. Call, just something chilly here. Call Rex return. Okay. Yes, that's chill skis. Um, for sure, anything after this point is just nothing. So we can just jump. We can go here and check out what the rest of this is. And we're gonna do this Zora stuff. Compare this to 0. Okay, okay. Move that in RCX. Move that in Rex. Call Rex. Set O to L. We're gonna return. If we don't return, then we're gonna do this. So this small jump here. Alright, well let's run this up into a debugging 10 and see what happens. See what happens with it. So I'd like to take a look at the debugger. So we're actually gonna run our thing here. Up to a debugger arena. We're going to launch an executable. Fuck me. Target debug, build, examples, override hook. So we're gonna breakpoint, overwrite, underscore, hook, overwrite, underscore, hook, and it's gonna load effective address. So look at the locals here. So original print name is pick out, and of course, fucking shit ass. Bro, I'm gonna remake this one day, bro. I don't give a fuck. The fact that you can't paste a hex string, please just fucking die. In game though, in game though. Alright, so our function's good here. So that's chill. We set this. Okay. Can we look at globals? Watch original underscore print underscore name. Unable to bind. So we can't actually watch globals. That's kind of annoying. What the fuck is happening? And we ride it, and we own it when I get inside it. I guess I never got rid of the compile cargo build. And we ride it, and you moan it when I get inside it. Alright, so we will go into print name. And then we will turn into assembly stepping here. So, okay, let's take a look here. So we're gonna go through, do the normal stuff here for print name. So this call to Rex should be this first call, which was called new display, so we'll just step over that. Move stuff in the stack. Okay, we got another call here, which will be this one. Arguments new, in which we will just step over that. Okay. And then we'll be calling print. So that should print. So the input value was koi, so print that off. Now we're going to move a value in RCX and RAX and jump to it. So I guess we're loading effective address. the original print name. And then we have to actually go to our next jump here. So remove this vector address. Then we're gonna go into our jump, which will bring us to our extra detour bytes. Alright, so here we are, extra detour bytes. And then we're gonna call this function once log. So we're gonna call that. That worked. Then we're gonna move Rax onto the stack, and Rax is let's see, what is Rax here? So Rax is a pointer to our function. Okay. Rax is a pointer to the function, so we move on to the stack. So we're gonna step over that. Okay, we're gonna move 1 into EAX. Alright, so I'm assuming that has to do with, let's go to right hook. This thing right here. So what the hell just happened? Let's restart that real quick. I think we just hit a bug in our code there. So print name. Let's go down to this jump to Rax. Step into there. So we got fucked up. Let's see. So we properly did the call here. So that call worked. So we're gonna that call worked. We jump if not equal. I think that's where we run into our problem. So yeah, this fucks up the assembly. Right, so the original is we'd move this into here, then move 1 into here, whatever, then we jump, if not 0, we jump to here, which jumps to something that's not this. Let's restart look at this again so I can actually see what it's supposed to look like before it does a fucked up jump. Do I have that breakpoint there? Okay. So we see what's happening here. So we come to this jump here. It's supposed to jump to here, but because it is fucked up, because we extended the bytes, the jump actually jumps to the wrong memory location, right? And so it's just executing at the memory location which breaks this. Right. So for these short jumps, it's gonna be a bit of an ish. It's gonna be a bit of an ish-arena here. Alright, because we're extending these bytes here. In which it doesn't know that though, right? So these little short joints. For this one right here, this could be fucked up also. So you look at these, so these near or these short jumps are going to be an ish-ing 10 with all dead. So yeah, jump conditional shorts. So these are going to be a problem, OEM. So we can't actually just ignore them because yeah. So let's take a look at JCCs. So JCC. We're going with the 7.5. So that puts us handling a jump if not equal relative 8. Jump short if not equal relative 8. Alright, which is what we're doing here. And then we have also or a jump if fuck me. A jump if fuck me, huh? I can't remember, but Yeah, let me take a piss real quick. Correct.
Bitch that don't be scheming, I ain't never seen it. I pull up and get between it for no valid reason. We up at the Four Seasons, we committed treason. We done trashed a bitch room and Jeffrey took a visa. I was born to be a skeezer, think I'm Ebenezer. I take a slice from your pizza before I even greet ya. I give no fuck about none of you niggas, I don't care to meet ya. And I give no fuck about none of these hoes, I won't ever need ya. We was at the school under the bleachers, finna rob a teacher.
Okay, so with these short jumps, we're gonna be a bit of an issue because we're modifying the instructions. Right, so we're gonna have to figure out an algorithm here to fix this sort of thing. Now, I think I'm gonna take a walk, a thinking walk, and think about it, and then come back and work on it. I believe is what I'm gonna do here. So, 'cause honestly, I'm not very sure what the best way to do this is. So, take a little break, come back. I think I'll just leave the recording on. Um, so if you're still if you're watching this right now, I don't know, go take a break, come back, and go think of a way to implement it. Yeah, man, it's always a good thing to do here. So, anyways, yeah, probably back in about 3 minutes. Let's see where my phone at here. It's clothing flush outside, so was born to be a skater, called me Ebenezer. How the fuzzle do I want to handle this though? You have to do. What's what you can see. So the walk didn't really go that well because it was fucking cold as hell out there, so I decided to just come back. But yeah, that's tough. Ah, fuck, I don't know how I want to handle those conditional statements for these near short jumps. 'Cause I'm trying to think. I can't really think of a good way to do that. Like, fuck.
Bands in my pocket, but bitch don't think that I give them out. If you try to take it, then the squad gon' come dry your house. Bitch, I'm the man, fuck everybody you talking about. You don't understand, you can go ahead and walk it out. Ounces, 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 yes we smoke up a
Up a
large
large
amount.
amount.
Pussy, you don't even know what's up. That's a bank
So,
account. I
fuck,
just
man. How
want
exactly
you
want to do this?
every time I fucking step out. Pussy say what's up, or you niggas better step down, bitch. It's the king, and I'm on y'all land now. Money getting longer, I got power
Because these
in my
relative
hands now.
jumps
I just wanna
are like
fuck
this thing just jumps
up
0xc,
my grandchild. Went to buying
right?
zone, fuck with no grams now. Pussy niggas talking, they just mad that they let down. Bad
But then
two
if
play,
we
got him
change to a
thinking I'm a
move
face
into
now. Niggas think
RCX,
they hard, but they softer than
right?
a
And then a move
reptile.
Rex and then a
If you
call
pop a
Rex.
line out, eat your fucking flesh out. I was born like this, you can check my DNA. They say
Excuse
I
me.
was a monster, then I stepped into the game. These niggas do not want it, I promise that on my name. Since I've been getting money, I just watch my life change. Don't throw money in hoes, cause I'd rather eat and save. Fuck the strip club, rather smoke weed in my place. If you ain't got no
I
money, get the fuck up out the way. If you ain't got no money, get the fuck up out my face.
so we can't turn it to an absolute jump, right? Because these will change and push down the IP or push down the memory, right? So um let me think. So if we wanted to do this for all conditional jumps, I guess we'd want to, or for all short jumps, we'd have to track them somehow, and then track how many instructions come in between it. Smoking dope and ties on a dope, a knife, let's get, fuck me, okay, let me tuck, blicky tuck, keep my blicky tucked. Maybe a lot easier if we had to separate into basic blocks right here. But, really want to parse it into basic blocks. It seems kind of fucking annoying as hell. But that would probably fix this problem though, because then we'd know where we'd have to jump to, and so we'd be able to update that based off of this. But what's an easy way to do this? Smoking dope, getting high, so I fucking know. Mm-mm. So JCC short. So let's just log here. Let's get its displacement. So jump short. Let's grab its so if it is a jump short or a JCC short, I want to see its uh JCC. So I want to see its memory or its displacement. Or I guess it's an immediate value. Right, so it'll be an immediate 8 value. Grabs immediate operand. JCC with let's run this real quick. After loading stuff, loading that shit. See, this immediate 8 thing doesn't actually even work. Try to U8 will change anything at all. Yeah, so no, it's not. 64, huh? So my nose isn't a register, but it's telling me it's a register. I guess it's just default. I don't fucking know. Like, how the fuck do I extract the value? Let's try getting the memory displacement. See if that works. Memory displacement size. Let's see if this displacement size is 1 or what's gonna be here. So is that not displacement, I guess. I don't understand what the fuck this it's an immediate value, but I don't understand like what how the fuck do you I just don't get it. Like what? It's a relative 8. So rel 8. That's all I can find. Okay. Uh rel. I guess we're just gonna do this and then subtract the fucking IP. Cause like it's just pissing me the fuck off, dog. I don't know why you have to do that, but I guess we'll minus ins.ip to get the actual displacement. So displacement JCC. Okay, so now it understands what it actually is. It's getting 0e because it's not calculating minus ins dot len. Used for as used for fucking pussy. JCC. Okay, now I want to calculate the right thing. Because now we know its actual displacement here. So that's its current displacement. We want it to be so it's 0xc. I'd like to count how many instructions that is from here. Uh, that gets our displacement properly. And I want to know, I don't know, how can I pass through? Thing is, because like we'd want to store this somehow. So we have to turn this to a structure, a disassembler structure, I guess, that actually will store the places in memory where we have a displacement, right? Or we have a short jump. So if I had my own structure here called like uh my disassembler, right? And we can store uh JCCs, right? And we store their index, which is DE size, right? Well, no, that's probably not how we want to do that, but I'm trying to think, bro. I don't really know how to do this. So, node 0x0 0xc. It's gonna pass all of these and go straight to here. All right. Then these two are turned into a move rex and a move RCX and a move rex, call rex. So we'd like to say it jumps this instruction instead of jumping to a conditional. All right, that's the thing we want to do. So I could store a hash map. If I were to store a hash map here of instructions, all right, and we just have like an instruction. All right, well, these would be uh, short underscore jumps. And then we just have references to the instruction that it's attached to, right? I guess this wouldn't be a hash map, but you just have like this. All right, it would just be a tuple. So it'd just be a backup tuples, I guess. And it'd have a single, like, this would just be a JCC and the instruction that it jumps to. So it was gonna be short jump and the instruction that it jumps to, right? No, okay, whatever. Like that's sort of something you would that I would want to do right there is have it like that. So it can store short jumps where they jump to, and then we could then afterwards iterate over the instructions, right? after we're done processing them all. Iterate over the instructions till we find the short jump. Because we can't actually store indexes because that wouldn't work, right? Or we could store a hash map of the original addresses. Like it would just be a hash map of the original address of the instruction to the actual instruction, right? To the what would be the instruction and then new address. So we could do that. And then we could then iterate through these until we come across an instruction that is a conditional. Right? We would then check to see its original memory displacement, then loop, and then we could then check the hash map, be like, yo, hash map, give me the instruction that corresponds to this original memory location, right? And then it would pop that out to us and be like, okay, that's its new address. And then we could compute the new jump. I think that's how we want to do that, actually. Right? Does that make sense right there? Uh, and so instead of storing all those in a vector, we could store it into a hash map. We don't really have to do a my dissembler either. We could just make a hash map here. Type instructions equal to this. And we could get rid of that. And we could turn here, we could return a vec of usize. So the old instruction, or the old address. So its original address with the new instructions and its new address, right? And then here we can have instructions. So let instructions equal instructions hash map new, right? And its type will be instructions. Instead of encoding them afterwards here, we can just say for ends and new underscore ends dot iter. Or not really dot iter, we can just like that. Just turn it into a consuming iterator here. Say instructions dot insert. So this ends here will be an inch be original underscore address. The instruction itself and then new underscore address, right? So we'd store them by original address with its instruction and its new address. I believe that makes sense there. And then all right, and then at the end we will just take so let's first get that working here. Yeah, so we won't really worry about all this. We'll first make sure this actually works here for parsing this. So then in here, we will just not worry about this for now, right? Or we can worry about that for now, sure. But then here we will just so create call from indirect calls. Let's go to here. So create jump from indirect jump. We return instructions, right? We actually want to return use size, right? That's what we really want to return here. Here, same thing. Create jump is chill. That's all good there. So how do we actually want to do this in the code now? So here, this will be. So we need to have its original address. So let original address equal ins.ip minus ins.len. Here. Okay, so that's gonna be our original address. So each of these will have the exact same original address. Original underscore address. Okay. The new addresses will be different. So new ends one will be original underscore address. I guess this will stay the exact same actually, that'll be the same address. Um New ends two will have actually the original address plus new underscore ends dot len. Right. Uh-huh. Yeah, I think that's about how we want to do it right there. So let's do that for all of these here. Right, so that will return back the proper things here. So this is the case here, then we will just push in ends.ip as usize plus minus ends.len. And then this will be the exact same thing. We're not modifying its address at all. Yeah, and then so when this goes all the way through, we will then be able to check, right? So we can just try to compile. So cargo build use hash map. Okay. Okay, so this should just be the same thing here as that shit I did there. So just be that. That's his new address. So it builds. Let's not worry about this stuff for now. So in our code, actually, koi hook. Overwrite hook. Let's just not do any of this calling stuff and just print stuff out. So like a log info and instructions. Well, actually, let's for ends in instructions dot header. There's my log info original. Uh, ends. All right. Okay. So here I would like to, we'll say if ends dot is underscore jcc underscore short or ends dot is jump underscore short. Then we will cache or we chilling here. We can then say, so if we do find that, if we do find a jump short here or something, we can then grab its memory displacement. So grab its displacement. Right. We don't actually need to do this. We should just say minus original underscore address here. I believe. Just log info, this displacement, make sure. Jump. Alright. Am I saving original address? No, I mean I'm saving it right. I guess we'll just do minus. Well, the original address is the ends minus is the IP minus the length, right? IP minus the length. So we should just be able to say this minus that, right? Like I don't know why we can't do that. Like I said, jump if not equals short is obviously 0xc, right? So it's not going to be 10. I don't know why it. Like if we add 10 minus 2 gives you E. Gives you E. I don't know why. Why is it originally 12 and then off by 4 is the question. So what if we just did the same thing we did up here? That's not gonna do it. I don't know why. Okay. It doesn't make much sense to me, but okay. Alright, so from this displacement, we would then want to say original address, alright, plus the IP, or plus the length plus the displacement. So original underscore address plus displacement as usize plus ends dot len will be equal to jump underscore address. Right, so jump underscore address. Then we'll say instructions dot, I believe it's a get, pass in jump dot address, let instruction for this, and then let's log info instruction. Jump is not equal to 57A, right? That should be the original address. So where the hell is 57A? Why the hell is this computer in the wrong address? Do we have to do? I guess we can just say n ends.ip plus displacement. We have to add ends lane also, like done. So looks like that's what we need to do. Not sure why the JMP. All right, so that if it found the instruction properly, right? Um, so let's print this out in hexadecimal. That pissed me off. JMP. Yeah, so this is it's a new address, which is the exact same though, but it's not, is it now? It's just not the exact same is the problem here. So why does it say it's exact same? Because my fucking implementation here is fucked up. So to check that out. Um, because when it comes back here, it doesn't actually. It just gets the IP here for every single one of these. We don't actually want to do that. We want to so let mute IP equal address, right? Or I guess original underscore address as U64. Or we just keep it as a U5 actually. And so here we would have to increment. So insert here IP plus equals instruction dot len, right? And then so then when we're processing the instruction, we'd want to just pass in the IP minus the current length, right? If we do that, and we'll be passing in its current address. So we can take it and make current underscore address usize. All right, and then this can be the original address, and then new address will just be current underscore address. And we'll have to pass that here, current underscore address here too. Current underscore address. Right. And here we can just take the address here. And the new address will just be current underscore address. Right here, it will be current underscore address plus new instruction length. So we're gonna be having duplicates is a bit of an issue for these here. So I guess for here, we're just gonna be adding in new underscore instruction 1.len because yeah, it's gonna be giving us duplicates and hash maps you can't have duplicates, right? So so for here, do the same thing. It's gonna be current underscore address plus that, and this will be current. All right, that should be Gucci with it. So let's go to JMP, in which it also finds it, and it finds its new address is at this point right here. So 156.9. Okay, so 1.5.6.9, huh? Hmm. a bit of a problem here. So for JMP here, repeat is conditional. I'm not. We then extract it from the hash map. Right. Going down the list here, it should then. So 7A should be down here, but it's not. We have 7C. So I see 2C right there. Is it the wrong address? Which can mean we fucked up our math somehow, somewhere. Because it's supposed to have 7A. Maybe we leave the IP here. Right. So maybe we don't do all of that. We're just gonna leave that as it is. For the lack of God, that's without a doubt. Cool. Oh, I just realized fucking hash map isn't ordered. Oh my god, so these fuckers aren't ordered. I was like thinking ahead, what the fuck is going on with this ordering? And then I just realized hash maps aren't actually ordered, so I'm iterating over them. It just looks retarded, but yeah, okay, it looks like it's good to go though. Because we found, so we have the jump here. We see that it jumps to this address. Um, and then if we can actually go to the address, so we see it up here, original. All right. Why is its new address 1564 smaller than its original address though? Something we gotta think about here. So what exactly am I doing wrong with that? So let me IP original address. An original address IP is being incremented here by each of these fuckers. Yeah, all of them are smaller than they originally were, even though they should be bigger though. That's not quite right. Isn't that the fucking case? Fucker like a god, that's without a doubt. Um, so let's take a look. It's because adding the instruction link, these instructions, let's print off their length real quick because when you generate these instructions, their length is actually kind of fucked up sometimes. I remember that. I don't know why that would be. So 0, 0. So we generated two new instructions and it passes in 0 as the instruction length. Yeah, so that's what's happening here to our addresses. Um, that's so IP minus install. So that's a problem, right? Because if we're trying to increment by the instruction length, but then the instruction length is 0, that's not Gucci for us. I ain't finna cap. Install or len. So instruction. So this is just informational. I guess we'll have to set the fucking length ourselves here. So let's go ahead and do that. I don't know why the fuck that even is, but mm, so we only ever create new instructions here and here. So create jump one. Okay, that no, I don't know about that. Turn it back to there. So here, let's set new instructions. So new underscore ends dot len dot set underscore len. So how fucking big with this move 64 underscore firm relative address? See, thing is, I don't know, like, what the fuck, why doesn't it just automatically calculate this for me? Instruction get underscore len? Like, I don't, size, maybe? Memory size options, like, what the absolute fuck? Okay, let's make a function called get instruction length. So pub function get ends underscore len to return back a usize. It will take a reference to an instruction and then it will create an encoder and encode that shit. So go create encoder. Encoder dot encode ends and it will encoder. So encoder, let's see, len. So if you encode it, returns size. So let's size equal this. Just unwrap this. Expect fail to extract. Oh, we actually return a result from all of these. We're going to return a result. I didn't realize I had a result propagating up or error propagation over here. Uh, So we will just calculate the instruction length. So get underscore ends underscore len of new reference to new underscore ends. So let len equal this underscore ends dot set underscore len. Take your mama's house without a doubt.
She ain't nothing but an internet hoe. Seen her on my dashboard, didn't even know. Boy, I'm cutting plastic, sitting on water like a boat. Bitch, I made a whole movement, niggas better take notes. Polo PJs coming out like young Dro. Put a blunt in the air, disappear like smoke. Make your little bitch melt like butter on toast. It's a new summer, bitch, nigga, make a toast. Only shore when it's water, nigga, like a rainbow. Beat a nigga silly, then make him run home. Then follow with my bitch, boy, Cuba be at home. If she want a southern boy, Memphis 10 be my home. Hate trying to please girls, cause they hate when they alone. But I swear, when I'm done, all she wanna do is bone. Say
So
she
you
wanna
want
take
to
it
take it
slow.
slow.
Where you wanna go, drive around
Uh,
the city slow.
oh.
Let the people know, everybody wanna know how I do it. Oh, I just wanna touch the soul. The fish spirit close.
David Egan. His girlfriend was killed on that same road July 4th, 1 year earlier.
Lengths all look gooch a with it. Okay, cool. So that's a length fix. Um, so now we have a jump here in which we actually calculate the right thing, and it
Say
is
she
looking like
wanna
it's
take it slow.
probably a real
Where you
address.
wanna go, drive around the city slow.
So,
Let the people know,
no,
everybody wanna
let it
know
go.
how I do it. Oh, I just wanna touch the
Make it
soul.
slow.
The fish
Mm,
spirit
mm,
close,
mm,
drive
mm,
around the
mm,
city
mm,
slow.
mm.
Let the people know, heartbreak kid, oh, I'ma
Alright.
make the show. Say she wanna take it slow. Where you wanna go, everybody wanna know how I do it. Oh.
Okay. So now it's going to implement what we wanted to implement in the first place, which is now to go through and actually update these JCCs here. So we get the displacement. We can then get the jump address, right? So we get the jump address, we get the instruction, we can just print it out here. Oh, we need to print it out. Uh, we can then, oh, we can calculate it. So we get this address, we take instruction. So we have this, and it's a new address. Uh, and is that just an address here? So we can let difference equal ends underscore new underscore address minus jump underscore address, right? So that'll give us our new difference. Or new underscore displacement. Then we can add our displacement. All right. So that'll give us a new displacement. Or actually, we could just take our address. So we actually, yeah, we can just take a new underscore address minus ends underscore new address. Or like this. And then we can set our displacement. So ends dot set underscore displacement. I think you can do this. Though we can't really do it here because this is an immutable iterator. But look at this real quick. Set so displace it's not actually displacement, it's memory displacement. So memory displacement 64-bit. So we can call just this right here and set the memory displacement to our new displacement, which will take a U64. So that would be kind of what we want to do, except this is not because we won't be able to call iter mute and then call get here because we'll have a mutable reference and we'll have an immutable reference right here, and this is not how it works, right? So yeah, I mean we can contract compile, but no, it's not gonna work here. Or maybe it might. Is it at vertex can't be borrowed as mutable? We can't borrow it as mutable because then this thing will go haywire on us. So we're gonna have to do something different here with this sort of iteration thing. So we're gonna have to just store uh, a list of jumps. Yeah, so let short underscore jumps equal that u size. Let's do that. So here, instead of setting this place, we're just gonna say short underscore jumps dot push. Okay, so we'll just push in these short jumps here. And then we'll just come in here like this. And then we will just go crazy on them with it. So for short underscore jump, so for jump and short jumps, I'm gonna be doing this right here. So we're gonna let our ends and new underscore address will be equal to the hash map here. So instruction get underscore mute the jump dot unwrap. So we know it exists, so we can just unwrap it because we just checked it. Um, then we can leave the rest of this the same right here. What? Yeah, that's gonna be a problem. That's gonna be a problem. How do I want to deal with this right here? So we can't. Not sure why this matters at all. Well, it's because it's storing references. Alright, so if I fix that, put usize found at usize. At usize gets me to pass in the reference to that. The bar occurs here, image bar occurs later, image bar later used here. Yeah, so we're gonna have to do something with all that. Do something with all that dough. We probably store the jump address actually up here. Alright, and just have it be a vec of jump addresses with that, and then jump address. The only we need it's a new address, so we're gonna actually store its new address here. We can grab that over here from the jump address. Right, and then new address. There, jump underscore address. Could be jump underscore address. Minus that. And then, yeah, so that will fix all that. New address will have to be dereferenced. Maybe. Ends underscore new address. Probably dereference that. Alright, cool. So now we're good. So I'd like to see. So I'd like to log info old short jump. So this ends New short jump. What's this? I don't worry about that there for now. And then failed to get, so we're just gonna get rid of that. Oh, so it's oh, that's not Gucci. So this thing is setting not the displacement value, but it is setting it to just an entirely new address. So I guess we're just gonna set it to the new jump address. All right. Yeah. So now I guess we will go through each instruction here. So for ends, or we're gonna go through for ends. Oh, can we loop through values here? So instructions later. Let's see. Hash map. Address dogs hash map. So can we just go values into values? So I think we're just gonna say into values. So for ends new underscore address equal to instructions dot into underscore values. We will encoder dot encode at ends at new underscore address. I'm gonna return this, and then yeah, find new size, so as U64. All right. So now let's go back to our overwrite hook here. Let's go on ahead and add this back in here. And then let's go and run this up in debuggington with it. So I guess we should go run this first here, see if it breaks or not. Breaks, status violation. Let's go see why. A fucker like a god, that's without a doubt. Which give me head, that's without a doubt. So we go into print name. Alright, so this is our new function here, and it's already looking a little bit sketchy. There's no RSP, it's down here. I'm not sure what the fuck happened here. So the overwrite hook should start off with an RSP subtraction, so already looking a bit odd. So it fucked up here. Let's put access violation. Okay. Question is, why in the hell is there an iterator? What the fuck? How the hell did we get into an iterator? So I don't understand. So again, this thing's different than it's supposed to be. Reacts is nothing, and we call it accidentally instantaneously. And that's probably because a hash map is unordered, and so therefore it's in a random mass order, and it doesn't let me know what the hell's going on, isn't that right? So it looks like we're about to change this to a B tree mappington, and which is ordered by address. So let's do that. B tree map instead of a hash map. So B tree map. So it has into values, so we could just rerun this here. Disassembler B tree map. So instructions. So we change it. Okay. Plus one DBG and see if it is how it should look. Okay, now it's how it should look. Okay, cool. Now I can actually look at this and go through it. So we're just doing the normal stuff here. Normal shit. Okay, dope. Some moving tones. Okay, now we're calling Rex. This is our first call from the function, so it should be this right here. Which it's not. I'm not entirely sure what the fuck the function this is right here. Not sure what's going on there. Exception needs to be handled. That's not good. So what in the fuck happened down here? Okay, so we start off good. 2C, 30, 38, 64. Okay. Move. Okay, RSP 30. And we go move RSP 68. Smash 68. Okay. We go RCX, RSP 50. Okay, RSP 30. Then we have a call here, which is missing. Now, why the fuck would that be the case? um, uh, let's not do that there. Let's see. So, code instructions, new address. Mm-hmm, 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 mm-hmm. Mm-hmm, 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 mm-hmm. I'm just not entirely sure why that's happening. I'm about to probably debug and look at all this stuff here to see what's going on with implementation. We're changing everything up to handle this thing. We can always take a look here and see the conditionals are right. So let's go view Disassemble this region real quick. I'm just opening something in reclass. I'm gonna actually look at this shit. So let's see, are these conditionals right? So jump if not 0 to 0, 3E. No, that's not right. So we're off by 1. 3F jumps to 3E. So we're getting closer. Still off by 1 there. What about any conditionals in here I can look at? Condition. No, there's not. Okay, so we're off by 1 here. I to figure out why that is. But anyways, I'm gonna call it there probably because I'm getting kind of tired with it. So that was a fun time. So we'll probably work on this again tomorrow. A lot of stuff to work on. Might come up with an actual. Well, I think we'll fix this problem and then come up with an actual like good interface to do this from. And yeah. Anyways, catch y'all next video.